Welcome to Study Loop.
Okay, so this is problem 24.81, and this problem, we have a lens, a glass lens. So the refractive index of this lens is 1.33, and we're going to coat this lens with a coat that has a refractive index 1.38, and we want this coating to be anti-reflective for both of these wavelengths. So for one of these wavelengths, so what should be the thickness of the coat so that 450 will not be reflected, and what should be the thickness so that 720 nanometers will not be reflected. So we can say this is the length and this is the coating, and the refractive index here is 1.38, refractive index here is 1.33. So when you have light coming from here, it will go from lower refractive index to higher refractive index. So the reflected light will have a phase difference of 180 degrees, and the light going through here, it's going from a higher refractive index to a lower refractive index, so it will not suffer from any phase difference. So the phase difference between these two beams will be 180 degrees, and so the condition for uh, destructive interference will be that the path difference, which is 2t here, is equal to an integer of lambda. And because we're looking for the minimum thickness, so it will just be lambda, right? Because when it's a multiple of lambda, these two rays will interfere destructively because they are out of phase. Okay, but actually lambda here is different than the lambda in air because it's inside this medium, so it should be lambda over n. Okay, so T1 will be lambda 1 over 2n, which is 450 times 10 power minus 9, or we can actually just write it in terms of nanometers, and the thickness will be in nanometers as well. So 450 nanometers over 2 times 1.38, and this will give us 163 nanometers. For the other case, T2, for the other wavelengths, it will be lambda 2 n, which is 720 over 2 times 1.38, and this is in nanometers. So this will give us 261 nanometers. So this is the minimum thickness for these wavelengths for the coating to be anti-reflected for this wavelength, T1 here, and T2 is the minimum thickness for this coating to be anti-reflective for the second wavelength here.